In this lesson, we are going to learn about starting, entering, and saving recipes and calculating and comparing their formulas, some theory about oxides, formulas, and analyses, unity versus non-unity, theoretical versus actual materials, normalization, and the materials database. If you are new to Insight, you should watch the overview lesson before this one. I have launched Insight, and the main window has appeared. I've selected lessons from the materials table pop-up menu on the lower left. Insight will reopen this each time I launch it in future. This static materials database is mostly theoretical and not up to date. However, we use it to demonstrate Insight so your calculated numbers will match mine. Insight supports side-by-side recipes here and indicates which is selected by highlighting the column header. Let's review a little. To select a recipe area, use the Recipe 1 or Recipe 2 items in the Utility menu, or their keyboard equivalents, or click the desired column title button in the recipe or formula list. There are several ways to start a new recipe. The first is to do nothing. As you can see in the Recipe Detail panel, we already have 2 new recipes. Insight deems a recipe new if it has not yet created a connection to a file or database record. The first time I save it, it will create a connection, and the recipe will no longer be new. If I already have a recipe open and want to create a new one, then I can click either of the Recipe Close buttons or select New Recipe in the File menu. It simply closes any open recipes. While I have this menu open, I want to point this out. Insight can be configured in Preferences to maintain recipes in files or in an SQL database. The main open item maintains recipes in the current mode. This opens them in the other mode. Thus, we must be in database mode. To confirm that, I'll choose Open. Yes, this is the recipe database window. When you first start Insight, the cursor should automatically be here. So to enter a recipe line, just start typing. I have typed potash, press the Tab key, and type 23, and I'm about to press the Enter key. Here it is. Notice that Insight searched its materials database and found the material for me even though I just typed part of the name. Not only that, notice the line cursor has advanced to the next line and has grayed because focus has moved back here, waiting for me to type the next line. Something else is interesting. Even though focus is here, if I press the up and down arrow keys, the recipe line cursor will go up and down. This also works for these other 2 blanks. Of course, you can click on a recipe line to select it also, but when you do, you will notice that focus will only stay on the recipe list for an instant and then revert back over here. Now let's name this recipe. I'll click the Recipe Details tab. I have typed in the name here. Now let's save the recipe. I could choose Save in the File menu that we've already seen, but this little button does the same. It is split into 2, one for each recipe. Insight displays either half if that recipe has been changed and needs saving. When I click it, look what happens. It disappears, and Insight has assigned a new database record for the recipe. We now have a 1 material recipe with a name, and Insight has calculated its chemistry. By implication, this is, of course, the chemistry of that 1 material. As you might notice, this is a theoretical material. No Feldspar in nature has this perfect formula. Now I've clicked the first recipe line. Notice this. Why is the name here twice? The line label is shown on recipe reports. The materials list lookup is used to search for chemistry information in the materials database. Users of foreign language versions of Insight often need to label their lines in their own language while using the English materials table. Or you may need to label a recipe line generically, but make Insight use the chemistry for a name brand material, or vice versa. When you save a line, Insight uses the line label for lookup if you do not enter anything for it. If it finds a material, it completes the lookup blank and fills in the label if it was not specified. The one thing to watch here is if you are changing the material for a line. Make sure to change both the label and lookup, or Insight might be looking up the wrong chemistry for a line. The best policy when changing material is to erase the line label and let Insight fill it in with the new name it finds in the database. I want to make sure that Insight is calculating the chemistry the way I want. I want a unity formula where the oxides total 1. So notice that I have the RO unity calculation type selected for recipe 1. I want to see the potassium and sodium amounts explicitly rather than combined, so I have unchecked this box. Before continuing, let's talk about oxides. An oxide is a molecule like K2O or Al2O3. It's a combination of oxygen and another element that naturally combines with it. Each has a symbol, a short, and a full name. There are only about 10 oxides that you need to learn about. Each has specific contributions to the fired properties of glazes. For calculation purposes, all ceramic materials and fired glazes are made of oxides. Oxides are divided into fluxes or melters, intermediates, and glass formers. Like any common glaze, this formula happens to have members in each category. I have set Insight up to display the equivalent analysis in the rightmost column of the formula list. This is a formula. It catalogs each oxide and its relative number of molecules. For every 1 K2O, there is 1 Al2O3 and 6 SiO2 molecules. This is an analysis. It compares their percentages by weights. Analyses are used when describing materials because we want to know what is in them. Formulas are used when describing fired glazes because we want to extrapolate fired properties from the presence, amounts, and interplays of oxides. Silica can make a good glaze all by itself. However, you need a cone 25 capable kiln and a super low density clay body to be able to work. To make it melt at much lower temperatures, we combine it with fluxing oxides. These have higher thermal expansions, differing fluxing powers, and respond differently to coloring oxides. To give the melted glaze some body so it doesn't run off the wear, and to give the fired glaze more strength, hardness, and leach resistance, we need this, alumina. But putting too much of this and the glaze fires mad. What's this? It is boron. It's magic. It is both a flux and a glass, and it comes in frits. Most of the traditional ceramics industry is built on this wonderful oxide. Only high-temperature glazes do not need it. We do not normally include these in calculations, but we do compensate for them. Everyone knows how much cobalt, for example, to put in a glaze to get the shade of blue that they want. These do not participate in the melt. Their source materials suspend in the glass and make a glaze opaque. It does not require calculation to figure out how much of these are needed either. A unity formula is simply a raw formula whose amounts have been scaled so that one group totals 1. Glazes are set at RO unity, materials lacking fluxes to R2O3 unity. This is an arbitrary standard in the ceramic industry. Insight displays an asterisk beside oxides that are part of unity. Notice these formulas are the same even though one is flux unity and the other is alumina unity, because theoretical potash feldspar has equal numbers of RO and R2O3 molecules. Now I'm going to change the amount of Feldspar to see what happens with the formula. I will click this up arrow. Each time I click it, the amount of Feldspar will increase by 4. But nothing changes in the formula list. This is a characteristic of unity formulas because they compare relative numbers of oxide molecules. As long as material amounts in a recipe do not change in relation to each other, the calculated unity formula remains static. Non-unity formulas are different. They do change when you change the recipe total. I made sure the first line of the recipe was selected and switched to recipe 2 and then entered 250 in the amount field and clicked update. Then I set recipe 2 to no unity. Notice the asterisks disappeared and the formula numbers are different, but their proportions to each other have not changed. Notice the RO unity formula weight. I'm going to change the recipe 2 amount from 250 to that. Non-unity formula 2 is now the same as unity formula 1. Why? Because 556.8 is the formula weight of flux unity potash feldspar. Notice the formula weight calculates to 556.58 for formula 2. Why? Because Insight does 3 decimal math. This is a recognition of the fact that ceramic chemistry is an inexact science. Most technicians would agree that even 2 decimals of precision in a formula is not realistic. The process of retotaling a formula so that no recalculation is necessary to unify it is called normalization. This concept is important in doing formula-to-recipe derivations. I will open the Materials dialog to show you. To do this, I'll double-click the first recipe line. I could also select Edit Materials in the Utility menu. The Materials dialog acts as a window into the active materials database. This is the information Insight knows about potash feldspar. You can see the full list of materials here. The name, alternate names, type, cost, formula weight, and LOI are here. These controls are used to find, add, remove, and edit materials. This is the chemistry. Use this to open your web browser on our materials site to get more information about this material. Although this formula has the same unity as the one in the recipe window, Insight does not force any kind of unity on material formulas in its MDT, and choice of unity does not impact calculations. You can use this dialog as a material pick list when creating recipe lines by locating the desired material and clicking this button to insert it into the recipe. Also, notice this. The formula weight of this is not exactly 556.8. It's 557.02. Again, Insight does 3 decimal calculations. That is enough to assure 2 decimals of accuracy in formulas and analyses. Before continuing, I want to point out that this dialog has menus. There are items here to import material data and the results of the current calculation. Now I'll click the Done button. Now I'm going to zero line 1 in recipe 2 and add a different feldspar in line 2 to compare. I've selected recipe 2 and line 1 and then clicked the Delete Line button. Notice that it just removes the amount for recipe 2. It doesn't remove the whole line because recipe 1 uses this material. I could also remove the number here and click Update. I've set the calculation type for recipe 2 to RO unity. But before continuing, note the formula for potash feldspar again. It is generic in that it has a simple formula with whole numbers that match a perfect theoretical molecular structure. I've done 2 things here. I've changed the amount of potash feldspar in recipe 1 to 49. And I've selected line 2 and recipe 2 in the recipe list and entered 49 of Custer Feldspar. When I did it, I just entered the word Custer because I know there's no other material in the list having that word. Insight has updated the line in the recipe list, moved the line cursor down, and reset focus to material lookup in anticipation of me entering another material. As noted already, there are 2 columns of numbers in the recipe list, but just 1 column of material names. Normally, you will be comparing 2 recipes that are very similar. For example, one might be an adjustment of another. Normally, a material that appears in both recipes will show amounts in both columns of the same line. You can enter the same material more than once in a list. However, when you save and then reopen a recipe, Insight will combine them. The calculated formulas here might be a bit of a shocker for you. The one on the right is a real-world material, not a theoretical one. Let's look closer. Here's the SiO2. This highlights how different theoretical materials that textbooks talk about can be from actual ones. They are also different from each other, of course. If these were 2 name brand Feldspars and I was substituting the one on the right for the one on the left, I would be able to use Insight to determine how much to reduce the silica powder in the recipe to compensate for the extra SiO2 that this material brings. Notice this number. This is the calculated thermal expansion. Notice how much lower it is for this one compared to the other. Now is a good time to consider for a moment how to change the order of lines in a recipe. Click on a line and drag it to the new position. Or you can move blank lines up into the recipe. When lines are moved, the order of both recipes is affected. We recommend ordering recipes with the flux sourcing materials first, then glaze, and then silica, and then additives for opacity, suspension, color, texture, etc. That's the end of this lesson. Please continue with lesson number 1B.